So first of all, many thanks to Emerge Australia for the invitation to share our work with you. I'm very excited to be in Australia, first time. And I'm very excited because I'm avoiding this. So very difficult to be unhappy to be here because this is such a beautiful country and this region is quite exceptional. So we don't have kangaroo, as you can see, but we have moose, and sometimes they are doing some roofing inspection, which I cannot recommend. You may not know, but we have about 600,000 cases of MECFS in Canada. Big country, but relatively small population. I'm wondering, is it because we're putting ourselves at risk of post-exertional malaise after every winter storm? This is from last week in Montreal. So I don't know if it's an exacerbating factor, but we must consider that. More seriously, I'm defining myself as a newcomer in the field of MECFS. I'm involved in molecular genetics of complex diseases. I'm better known for my work on idiopathic scoliosis and on osteoarthritis. But I've been involved since about 4 years now, and we developed the largest MECFS cohort in Canada so far. I would like to thank the CBLIC Foundation for their support, as well as CHR for the last planning international conference that we organized in Montreal in May 2018. And this study has been approved by St. Justine University Hospital Institutional Review Board. So today I will share with you some current challenges about the etiology of MECFS, especially the importance of the gene-environment interaction, of course, the lack of validated biomarker to better stratify MECFS patients, and also some methodology issues. I will briefly describe the Quebec MECFS cohort and share with you our preliminary data. So not everything that I will show you today is unpublished yet. We are still in validation phase. But I think we have pretty exciting results and that are connecting the dot with previous presentation that been presented since yesterday. So I think it's pretty clear for many complex chronic disease that there must be some kind of predisposition, initiation genes that will increase the susceptibility to develop some specific disease, and MECFS is no exception. But on the other side, we know that there is a strong predispositions to some environment factor. It could be viral, could be some bacterial infection, could be also chemical sensitivity that will be further exacerbated. And what is unclear is, with especially an aging population, is from the disease onset, very few will have a full remission. Most of them will continue to progress in the disease, unfortunately. And there must be also some disease modifier that will further explain and could contribute to the exacerbation of the disease. What is very important to understand is the gene-environment interaction. You can measure whatever you wish. So when you look at the genomic level, so for the genome, you can see variation, mutation. It's unclear if those variation mutations will really translate with something pathogenic, because they may have some redundancy with other family members that can compensate, or other pathways that can be activated that will attenuate the effect. At the end, of course, if you have a defective protein or less protein, or the protein is going somewhere else than is normal cell compartment, you may end up with some problem. And of course, there's a mixed response between your environment, the metabolite, the microbiome. The best example I can tell you about, we cannot just purely trust your genome, is the caterpillar and the butterfly. So if I extract the genomic DNA of both, and ask you based on the genomic sequence, who is who, you cannot say. By the way, I'm working in a pediatric hospital, so that's why I'm using this cartoon. Normally, it's more easy for everyone to follow. So So you cannot say. Why? Because you know that the caterpillar will transform in a beautiful butterfly because they're exposed to the environment, and there will be a lot of genes that will be activated and disactivated through epigenetic effect. So this is a pretty good example. And I'm not saying that MECFS, you guys will transform in butterfly one day. But I look about the logo of Emerge Australia, it looks very much like a butterfly. So correct me if I'm wrong, but I think the analogy is great. So the challenge, one of the challenges is the great clinical heterogeneity of MECFS. How we select and compare patients purely for research, but eventually for establish on more objective clinical diagnosis. So one issue that we had, and a lot of you present since yesterday about the clinical definition. Some people still using the Fukuda criteria as opposed to the most recent ones. That would be past, present, and future clinical definition for sure. So we have to be aware about that. Big issue about the use of small cohort with different ethnic background and also the multiplicity of omic approach. So there's not a single cohort in the world, with maybe the exception the one on Ron Davis, because Ron is using old Stanford technology for each of his patients, but this is quite the exception. But otherwise, we are limited to our favorite technology, favorite omics approach, and we are using because those are very expensive. So we have to be very selective, at least in the academic field. So we cannot use brute force and say, I will spend $1 million for each patient. That would be great. Probably useless, but we are not like the industry. So in academia, we have to be wiser and also more selective in the way we approach. But small cohort is something that we need to work together to correct. Patients are also at different disease stage. So not only you may have a small cohort, but you have patients that suffer the disease from only 2 years and other 20 years. So you are running after trouble if you work with that type of cohort, of course. So again, we have to make sure how can we distinguish the patient. And because in the real life, patients with aging have different comorbidities, so they are using different medication. So again, you cannot ask your patients to renounce to the medication for 48 hours because sometimes they can create some very serious adverse conditions. So again, in my cohort, I have some patients that are receiving 9 different medications per day. So we have to deal with that, and we need to develop what I'm referring as a pragmatic essay. That's not ideal based on the mind of researcher, but in the real life, we need to real human being, and we need to adapt about who they are and what they need. So also the fact that male and female behavior will be different. So there are sex differences, and also aging might have a strong influence. And also, what triggered the onset of disease might be different for different patients. So is it a sudden case or something that has been induced by a very bad viral infection? So we need to consider the whole history of patient, and that will influence the way that we are developing our cohorts. So we put forward the following hypothesis about the role of circulating microRNA in MECFS pathogenesis. Why? Because we truly believe that there are genetic predispositions that link MECFS and its pathogenesis, but also due to the great influence of the environment, we have to work with something that can bridge the gap. And microRNA are very well positioned to do that, so they are probably the missing link between environmental factor, genetic predisposition, and phenotypic differences observed in MECFS. So for this specific study, we wish to identify specific circulating microRNA links to disease stages, and disability of MECFS across our Quebec cohort to better understand the etiology of the disease and to determine specific molecular, epigenetic, and genetic mechanism associated with the disease. We need to find actionable targets. I don't want to list you 1,000 different genes, and none of them can be changed, even if we prove that this is a true mutation. We need to figure out ways that through actual or future medication or whatever the therapy, I can change it. So, but what is a circulating microRNA or simply a macroRNA? So macroRNA are small non-coding RNA, 20 to 26 nucleotides, And they are very powerful because they can interfere with the messenger RNA stability and translation in proteins. So one single microRNA can target up to 200 different genes, and many genes are targeted by several different microRNA. So small but very powerful mechanisms to regulate gene expression. Again, working with patients, I learned a lot of stuff as a newcomer in the field, and the very first advice that I received from one of my patients' collaborators was about, you need to focus on post-exertional malaise. Whatever you do, make sure that if you develop a test, the test must mimic post-exertional malaise. So I listened to this partner, and we developed a test that and then reproduce post-exertional malaise by using a machine that is approved by Health Canada to apply therapeutic massage on the arm. So it's an inflated cuff that have a very low cycling and apply a massage. And this is enough to create post-exertional malaise, and I will show you the data. So we developed on a discovery phase. So what we did is, this is the Quebec cohort. So as of today, we are probably around 200 patients. And of course, controls are lagging behind because each control needs to go through the stress test. So this is about 2 hours to do that. So it's not simply to have a draw blood or have a questionnaire. So you need to have people willing to give to science and give to MECFS patients and participate as control. So we have the traditional questionnaire, and you see the population so far are very comparable. So from the plasma that we obtained from the test at baseline before the stimulation and every 30, 60, and 90 minutes, we extract microRNA extraction, and we did the profiling using the Agilent technology. So we start with a potential of 2,500 candidate microRNA, and we end up with 32 microRNA differentially expressed. So this is our working panel where we have a difference in expression between MECFS either at baseline, between the patients, or between the patients and the control subjects. And so far, we have 9 validated at a larger scale, so on a large subset of our actual cohort. So why we think it's very important is using this experimental design, we were able to prove that, first, we don't need to know if the patient suffered for 2 years, 20 years, having different drugs, because each patient or each participant is being his own control. So this is a big, big advantage. The machine is a portable machine, so I'm sending my clinical nurses at home. So 85% of our patients are severely ill patients, so they are homebound or housebound. And what we think is that the stress-activated circulating miRNA will be more informative and specific than those at baseline. And eventually, if you are interested, the machine can be available to you free in Australia. So whoever wants to start it, to test it, I will make them available. So again, to validate that, we need a very simple technology. If you want to develop a diagnostic test, we cannot rely on expensive chip. We need to use tests that are used in regular clinical laboratories. So qPCR is used on a daily basis for different diseases. So we validate that using that technology. And keep in mind that all the remaining slides, when we start to present some result, we always have the data evaluated at baseline and also after 90 minutes of stimulation. So I will show you some data, not all of them because that will become boring, but each of them I think has a very interesting story. First of all, each microRNA, and I apologize for that, they have sometimes some complicated name, starting by MER, a number, and 3P or 5P. So not very original, but that's the way we can recognize them. So this MER 127 3P has been initially discovered in Australia. So by the work of the team in the Griffin University, and we confirmed that this is the same, so we have the same results in French Canadian. So this is the first, I think, replications that confirm our first Australian results. So thank you very much. We are very much similar without the snow. This one is very important. So in A, you see the result at baseline compared to control, and after 90 minutes compared to 90 minutes stimulation. What is important, we are using ingenuity pathway analysis developed by Chiagens to identify a known or predicted target of that microRNA. And that microRNA block BCL6, which is an inhibitor of interleukin-10. And as you know, this interleukin-10, this is a cytokine that has been found elevated in several spinal fluid of MECFS patients. So again, not only we confirm the first Australian results, but that makes sense in terms of the pathophysiology of MECFS. So we are targeting and starting to explain change that explain the elevation of this cytokine. With this second mir is the mir 145P. So this one is particularly interesting because it's targeting a molecule CD20, which is the lymphocyte B receptor interacting with the rituximab. So I think you have heard about rituximab, at least in the field of MECFS. So we saw that overall at baseline and at stimulation, so there's an elevation of this microRNA. So what does it mean for us? It means that if you have high level of this microRNA, you won't have the receptor to interact with rituximab. So you won't respond. You will be resistant to rituximab. So I have a discussion with Dr. Flug, and I will have soon the sample of his last clinical phase 3 study to try to explain the proportion of responder and non-responder using that. So one thing that is misleading on this slide is the fact that when you put all MECFS cases, you assume that they are all the same case control, which is quite wrong. Why? Because if you look at each patient, so the purple one is after stimulation and the first one is baseline, you see a lot of variability between the patients. So every patient that you see a strong elevation at baseline wouldn't be a good candidate for rituximab. So this is about 1/3 of the sample here. Another 1/3 is if you do an effort, if I stress you, you will have an elevation. So we're losing another 1/3 of candidate that could respond to rituximab. So it remains 1/3 that could be pretty good responder to rituximab, which match Dr. Flug data overall. So that makes sense. So we need to understand on the real samples, okay, in the next study, what is happening here. But I think it's very important that you keep in mind that even though that we present you MECFS case versus control, think about the diversity of the response for each of those microRNA. For this mir 155P, this one is higher expression, mainly at the after stimulation. So there is no significant change when I compare the case in control at baseline. So again, this a pretty good indication about why developing a stress could be interesting. And if we look about the diversity of response, so we have very high responder, so that produce high level of mir 155, and normal responder, and you have control. And when we look about different parameters, so we saw that the very high responders, so those that express the highest level of this microRNA, have a better mental fatigue score using the MEF20 questionnaire. So we said, wow, this is interesting, but what does it mean? So, and we rediscovered by using the EPA analysis that a well-known drug has been used in the past to target the same genes. So duloxetine has been tested in a clinical trial by the group of Arnold. And this group showed us the very same thing, that by blocking, this is an inhibitor for the SLCA2, which is a norepinephrine transporter. So, and he showed that this improved not the general fatigue, but the mental fatigue using the very same questionnaire. So this is very intriguing because two different methods, two different cohorts, and I proved the same point several years later by a different mechanism that is targeting the same mechanism. Now you would say, should I start to use duloxetine to improve my mental fatigue? The answer is no. Because long-term use of that, if you inhibit this transporter, you might develop POTS. Because this is molecule that is already mutated in some patient having POTS. So if you reduce the level of this transporter, you might at risk to develop POTS. So that's why it's not a solution. But again, this is just give you an example that the way we design our experimental approach make a lot of sense in terms of the understanding the pathophysiology, because we reconcile previous results, we confirm previous results from others by a very different mechanism. Another one is the MIR374B5P. So this one is very interesting because it has been shown to be involved in fibromyalgia, so a related disease, as you know. So the lower expression of this circulating MIR has been associated with women suffering of fibromyalgia and is inversely correlated with pain threshold. So we did a test in our Quebec cohort, so we have access to the Carthagene biobank from the Quebec population. So we tested 68 patients. Indeed, all FM show a very low expression level, and we are going, interestingly, in MECFS in the opposite direction. As you may know, there's more fatigue in MECFS than pain, and the pain component is more prevalent in the FM than fatigue. So this is probably a very interesting microRNA to discriminate for sure between FM and ME, doing that. And again, we show that at baseline and after stimulation, this one was increased. Again, of course, you can have so many potential targets, so you can have thousands of them, but that won't be necessary for today. But if you look about that, you can figure out a lot of relevant targets. For instance, this gene, TTPA, is involved in the tocopherol transport, so vitamin E transport, and as you know, vitamin E is deficient in MECFS. So we have a direct effect. So if you have very high level of this MIR, you have less of this transporter. So it makes sense that to develop a deficiency in vitamin E, as opposed to you can look about a different, your favorite protein. So think about intestinal disorders. So this is a connection with celiac disease, with allergic conjunctivitis, cognitive impairment, anxiety. So all relevant sector or domain connected to MECFS. I'm not saying that this microRNA explains everything, but it's a very powerful molecule, and we know that in that case, its elevation may disturb all those genes. So we need to pay attention about such potential. The MIR186 has also shown previously in the Australian cohort. This one is, we are going in a different direction because we are applying the stress test, which was not available in the time that the team in Australia did that. So this one is very interesting because, again, it's a good example that only the stress test leads to a differential response. And this one is the one that is the most elevated in the endurance athlete. So it's got a very high VO2 max. And you know there's a lot of relationship between MECFS and athlete. So these patients behave based on this microRNA and those factors as an athlete, but they are doing nothing. I just stress them during 90 minutes. So they are relaxing, sitting, but they have the same response than if they have running a marathon or a 100 meter in less than 9 seconds. So this is very important. And again, this one is connecting with different protein, connecting with the mitochondria abnormality, connecting with different formation of vesicle, EGE response. So we hope that we will develop collaborations to assess the best candidate gene. And by the way, elevation of this microRNA is associated to exposure to mercury. So this is something that I share with L'Oréal, so we will exploring the connection about that. So worker exposed to mercury will have a very high level of this microRNA, and they will look like athlete based on this microRNA, but that would create very serious disturbance in key genes that are regulating very important transport, for instance, in the transport of different iron, cobalt, copper, so magnesium, so those are very important. So the last of the series I'm showing you this afternoon is the MIR3623P. So again, this one is also only triggered by the stimulation, so the stress test, and again, this one is connected with different developmental lymphocyte, transport riboflavin, activation of B lymphocyte, daytime sleepiness, which is also relevant for some patients because there's an inverse in their sleep pattern. So that one can also contribute at that. And also this is the one that is overexpressed again in a plasma of endurance athlete. So again, we need to explore that because it makes a lot of sense to understand why you end up like an athlete, but you have not such a capacity. So you have only the end result like an athlete, but there is something wrong that explains that you are already at your top doing nothing. Okay, so I understood that, and we need to explore that together to understand in more depth about the potential of those microRNA. What I'm doing with those microRNA, so we have 32 to explore, 9 of them, so we develop a panel. So I will go as fast as I can. So I don't know if you can read the number, but each line is a very specific patient. In yellow, it's a negative difference between the 90-minute stimulation and baseline. And in blue is a positive score, so there's more effect after stimulation than at baseline. And we established a very primary classification that allowed us, as you can see, to classify the patient in 5 subgroups. I'm not saying that would be the definitive classification. That might be better microRNA in the remaining pool, but so far with 9 over 32, I'm able to have stratified patients, molecularly speaking, on 5 groups. What this mean to you guys? First of all, if we look about the comorbidity associated with each group, you can see that we have different variation. In group 4, have a lot of 60% of the individual classifying that group have throat H, as opposed to 31, 33, 36. So there's an enrichment here. So there's a different symptoms that can differentiate them. We can also see every time that we do the stress test, the nurse calls a few days after to see how are you doing. We never put anyone to the emergency room using the test, but they develop severe symptoms after the test. That's the principle to reproduce as safely possible a post-exertional malaise. So you see the first group relapse of the disease in 1/3 of the patient. We have different symptoms going here. I would like to point that group 4, half of the patients have no symptom at all, which is okay. We can tweak the machine and push everyone to have symptoms, but I'm very happy with that result. We need to understand why. But the group number 5 is the one that is very interesting because they are the only one that report mental fogginess, vertigo, dizziness. This group is maybe more homogeneous, and that can give not only clinical indication, but also useful subset of patients to go more in depth to discover what are the gene links to mental fogginess in patients. You have a natural enrichment using that. So, and what we did is through the questionnaire, so you can see that each group are here, and you see that the group 1 is the one showing the lowest daily activity, which is statistically significant as opposed to the group 5. You see also difference in general fatigue, mental fatigue, DSQ using the cognitive, and health. So again, each group, more or less, means something based on standardized questionnaires. So we use the tools that are already existing. We are not reinventing the wheel, but that tell us already something. So this is not just purely arbitrary classification. That classification seems, clinically speaking, indicates something. If I go back to the group 4 and the group 5, so the one with mental fogginess, and the group 4 with the one that has the highest number of individual reporting no symptom, we re-examine all our biochemical data. And interestingly enough, we measure a molecule called thrombospondin 1, or TSP1, which is an anti-angiogenic factor. And TSP1 attracted our attention because you see there's a decrease after stimulation in the group 4, but the most severe increase in the group 5, which is the one that report mental fogginess, vertigo, dizziness. So if you have to put few bucks on a bet, I'm sure Australian is doing some betting at some point. We won't do that today, okay? So keep your wallet close, please. But if we do that, if I create some constriction of my small or larger vessel by overexpressing an anti-angiogenic factor like TSP1, probably I could develop a mental fogginess or some vertigo or dizziness. The likelihood, I'm not saying it's the case, but what I'm saying is the very same patient tested, the elevation is only in the group developmental fogginess. So this is a lead for us to explore. And if I'm right here, there are 3 receptors for TSP1, CD36, CD47, and 1 specific integrin. We can block those eventually and develop therapeutic tools that can improve mental fogginess. If it's the case, that won't happen tomorrow. That will take some time. But this is a good example that by moving strategically to address and using a molecular stratification of patient, that can lead to some very specific therapeutic approach on the short term, not to cure MECFS, but to remove from the equation some severe symptom like mental fogginess. The patient will be very happy if we eventually, together, bring that on the market. So this is just a proof of concept, and many, many other steps are required to move forward. I've been asked since my presentation in Stanford to see whether or not we are retested the patients. So we started to retest the patient, and surprisingly, my student decided to not only test the patient 1 month later or 2 months later, they raise the bar. They start to test the patient 3 years later. So, and surprisingly, so you see first visit in 2015, second in 2018. So we saw some patients that remained in some group. Some didn't change, but some changed, and they developed more severity. So you see this group is from group 5 to 3, 2 to 1, 2 to 1. So again, I put the classification, and we start to explore. So this is very preliminary. I got those results just before I took my flight for Melbourne. So, but you see that this patient, for instance, the group 2 to 1, because their energy was so low, so they are they increase the severity. So in group 1, as you know, is the one that's showing the lowest daily activity. So again, this is pretty much a good example that those microRNA classification, because it's capturing what is happening in the environment. So they are not fixed. So it's a more dynamic response that will happen. So some patients will improve, especially when we will try something in terms of clinical trial. But others can worsen if we are not doing something. We need also to capture when or who is worsening to address those issues and to understand that. So I think this is the test. What is the test is capturing here is patient can change of classification, especially here after 3 years, which make a lot of sense. I told you that the microRNA will respond to change in the environment. So either we work on the environment and going back to the initial stage, or eventually by using medication, doing something more specific as interesting or promising therapeutic approach, eventually not only to have a group that will be safer, but eventually to remove you from MECFS group and going more toward healthy groups. We did that with twins. So we use identical twins, and this is a proof of concept, so using one set of twins that are concordant for MECFS, and one discordant. So of course, the discordant is classified here in the subgroup 1, and is very different than the co-twins unaffected. But what is very interesting here is this is two identical twins, both suffering of MECFS, but they are not in the same microRNA subgroup. Why they should? MicroRNA have not really anything links to genetics predisposition. They are bridging genetics predisposition and the environment. So why even in identical twins? So this is a good demonstration, I would say, about the influence of the environment because they share the same genetic material, more or less. And this is what we are capturing here. And you see that by using the standard test, you see some difference in some specificities. So they are not identical, alike but not alike. Very powerful tool. And of course, we will test additional ones. So if you know Australian twins, I'm open to collaborate because more we will test, more we will see the difference and try to understand together what is happening. So what are the next steps? Of course, we need to continue to validate on a larger scale the microRNA. I would be very happy to establish collaborations with you guys to allow you to test the machine, and after that, if you do metabolome, proteome, whatever you wish, your favorite way to address that, having baseline study plus the way that we can apply a stress test that I think reproduce relatively safely post-exertional malaise, that would be great. We need to replicate, of course, and I think the only way to be successful is working together in a collaborative manner. Finally, I would like to acknowledge all the patients that support us and participate because this is not an easy and trivial task. The task, as you saw, is very demanding. I, unfortunately, made them sick for a short period of time, and they understand that. Even when we call them for the second visit, anytime, they are very happy to participate. So again, we are doing that because we work with the engagement of patients to develop the test. This is not a test that's been developed by a single researcher, but by this partnership with patients. Many thanks to the associations that support us, to the Sibylla SA Foundation for the financial funding, CHR as well, and also many additional MECFS association across Canada and also in Quebec with the ACAM, because that's the key leaders that support us and help us to not only have patients across Canada, but also worldwide, because we have also patients and families that participate from different parts of the globe. My final thanks to my team. It appears right now it's only a woman, so it's a good thing, because we're addressing a woman-driven disease a bit. But we are open to recruit brilliant students, so if he wants to come, play in the snow with us, you are more than welcome. Thank you.
We've got time for a few questions, if anybody's got any.
Thank you very much for your talk. It was really interesting data. I've got two questions actually. The first is in regards to a lot of the graphs you showed comparing the CFS group and the controls. The CFS group had really huge confidence intervals compared to the other groups, I guess suggesting that it is a very heterogeneous group, and I think provides good justification to looking at those subgroups. I wanted to know, I guess, how confident you feel in drawing conclusions about those subgroups, because I noticed they were quite small sizes. I think one of them was about 3 patients in the group. So You've obviously got more plans to get more participants. So that was one question. The second question was in regards to the actual device used. I'm really interested in your exertion paradigm because we used one in our research as well. So if you could give us a bit more detail about the actual device and the protocol used for that device, how long it took and that kind of thing.
Okay, so for the first question, of course, we want to go through the whole cohort, and the cohort is expanding. So by qPCR is possible, but now I have to make a trend in my dilemma to increase the number for the 9 I already tested versus to go through and reach the 32 to further define which one would be the best in terms of panels. So we try to do both, and eventually, by using additional microRNA, it's possible that the group change, because I may cancel some specific. You see that nothing is perfect except one group is purely yellow, more or less, and sometimes we see some blue and things. They have also, we never play again with the threshold in terms of the differential. So what we consider really significant, is it a 50% difference that we are happy with, or 10%, we can consider that. So we need to develop the algorithm, but to do that, we need to go through the whole possibility, because I can assure you there are plenty of other more exciting ones that are not coming up. So right now we have 5. They give us a good idea about the symptoms and subgroups so that we can start to explore, especially the relationship between mantle fogginess and TSP1. So that will be very easy to measure brain oximetry, for instance, during the test and post-test, and see if it's dropping in that subgroup, but not in the other one. That will be a good proof to continue. So we have a pretty good understanding of the path that we have to adopt for that. But of course, we need to increase the number, but we have the number, so it's not a big deal. What I would like to see is that others try the same methods, okay, that you test your own cohort and see if patients develop post-exertional malaise and what type of subgrouping eventually, just based on the symptom, and eventually we can address and try to classify them and see if we have some similarities. The second question is about the test itself. I don't have enough time to go into detail, but I will give you my coordinate and I will send you the protocol and everything. This is a machine that technically you can buy, but I can have one free for you because the machine is not cheap. It's $20,000, surprisingly, okay. But I have access to some resources that can give us some free machine for research. So, but it's very easy. It's already setting, it's plugging, plug out. Nothing dangerous to do that. And eventually we will have a video for that, so I will circulate the video to show you that, but very easy.
In that case, I have a question. Did you find a difference in terms of how long the PEM lasted, depending on the subgroups, or the severity of the PEM afterwards, or was it just the symptom profiles that differed?
Yes, I removed that slide because I thought that I have enough. But of course, some patients say that I have a severe malaise for 24 hours, others say 72 hours, some a full week. So to address that in a more objective way, we will repeat soon the test with an intelligent vest called Exoskin, which is a Canadian company based in Montreal. And they have some offices in San Francisco that developed that. They even sent the intelligent vest on the space station. And that register the breath rate, the cardiac rate, movement. It's also validated to measure sleep disturbances also. So doing that, so the idea is to have a monitoring a week before the test, during the test, in a week after the test, to have all automatically the symptoms. So everything is downloaded on a secure server. So because now we are using self-report data from the patient, but as you know, patients have so many things. They are stressed just to answer to the phone to us. So we need to have more objective data to complement the questionnaire and direct contact. I think it's very important that we maintain direct contact with the patients. And the vest is very easy. It's like a sport bra or sport vest, for very adjusted, and we have different size. So again, if you are interested to try Exoskin, I will make them available to you. Okay, those are not cheap. It's close to $600. Okay, but for research, okay, Exoskin is willing to work with us because I think it's for researchers and for clinicians that can be a good tools to follow patients, especially patients that are in remote regions. So let's say you prescribe something or you want to follow a patient and you don't know, and patient cannot go back to your center because it's far away. So you can follow the patient at distance and say, whoa, listen, there's something wrong. I need to call you because the data are not good. You are in tachycardia for too long and too often. We need to do something. So that can be a very interesting e-tools for telemedicine at some point. Thank you.
Thank you.